Hi everyone, action time. Grade 12 physics, past paper questions. We are choosing questions from your past papers, final exam questions. We are starting with electric circuit question. Every lesson we'll try to finish one question with you. So some questions you will see easy, some questions also easy, but taking time. So you will see we are gonna study with you. So this is our question one. Question one, what they're asking, let's see. We have a circuit here, and then calculate the current. All right, easy question. So to calculate current, what we have to do first? We should remember Ohm's law. Ohm's law, current formula, what was it? Current equals voltage over resistance. Current equals, as you know, symbol of current is I. Current equals voltage over resistance. So for this circuit, as you know, currents flow from positive side to negative. We can draw, we can start from here and carry on. So this is direction of current. And then, as you know, electrons moving from negative to positive, but current from positive to negative. So let's say current is here. So you know total voltage, but we need total resistance. First of all, we should calculate total resistance. As you see, we have 15 ohms and 5 ohms in parallel, and then we are adding 20 ohms. Now we can see our answer, and then we can calculate current. Okay, first of all, between 5 ohms and 15 ohms parallel combination, this combination total resistance we are calculating, what formula we are using? 1 over R parallel equals 1 over R1 plus 1 over R2. And from this formula, you can write R1 times R2 over R1 plus R2, or you can just carry on like this, 1 over 15 plus 1 over 5. And then finally, you are going to have 4 over 15. This is 1 over R parallel, 4 over 15, but we are looking for R parallel, so directly we can write R parallel is equal to 15 over 4. And then when you calculate it, you will have 3,75 ohms. This is first option we can say, and second option, which one is easy for you, you can use. This is our R parallel, not total resistance. To get total resistance, what are we going to do now? We are using another formula for Rs is equal to R1 plus R2. This formula we are using. R1 plus R2 formula you can write first. And then what was the S? As you know, for this kind of circuit, let's write type of circuit here. So in our lesson, we are not just answering and go. We are trying to explain what we have to know and what formula we are using, just as a revision also. So if you have R1 and R2 for this kind of circuit, we are just writing Rs is equal to R1 plus R2. So this formula. And we are using this formula here. R total is equal to 20 plus 3,75. 3,75 for parallel combination plus 20. And then you are getting 23,75. Okay, now we can calculate current. Current is equal to voltage over resistance, total resistance coming from Ohm's law. Your total resistance, as you see, 60 volts over 23,75, and you are getting current 2,538. Okay, this is our question 1.1. I hope everything is fine. We have done our question 1. It was easy question because there is no internal resistance. Only 60 volts is given here. So it was easy one. If we have internal resistance, what's going to happen? You are going to just add R, small r, to your total resistance. Now we can go to question 1.2. 1.2, calculate the potential difference on 15 ohms resistor. Okay, so also we are using Ohm's law. We are looking for what? voltage on 15 ohms. Let's draw a voltmeter here. Voltmeter, just what are we gonna read for 15 ohms voltage? Okay, for voltage, what we need current and resistance, right? We know from Ohm's law, your resistance is 15 ohms, it's okay, but we don't know this current. So if you don't know current, you cannot calculate just directly, but because of that, we are using other option to calculate this question. What about this one? 5 ohms, same process, right? We cannot calculate for now. Why? Because we don't know current. Let's say V1, V2, we cannot calculate. V1 is, let's say V1, yeah, V2 equals I times R. R we know, 5 ohms, but we don't know current. We cannot calculate for now. And then, now let's continue with other option. How can we calculate V1 and V2? What we know, V1 equals V2. In parallel, always voltage same, just voltage. We have same voltage in parallel combination. We know that. So for this question, to get V1 and V2, they're asking you V1, but if you get V2, it's the same thing. So what about this one? This is our voltage for 20 ohms, V3. V3 is here. So we don't know current. Because of that, we cannot calculate voltage, we said. But for this one, we have current. We calculate already, right? In question 1.2. In question 1.2, what was our current? Just let's check. What was it? 2,53. Current equals 2,53A. I hope it's fine. Now we can calculate V3. But they're asking you V1. Why we are calculating V3? It is easy to calculate because we know current, we know resistance. When you calculate V3, 60 minus V3 will give you V1. All right, and V2, the same thing. Okay, we can calculate V3 now. V3 is equal to I times R. I equals 2,53 times resistance equals 20, and then what are we getting for this? 50,6 volts. I hope it is clear. So for this question, first of all, it's just to understand, we are explaining, we don't need those steps. Just calculating V3 first. V3 means, we are just labeling it, V3 for 20 ohms. You can just say V in brackets 20 ohms. You can say like this. All right. So we are calculating voltage for 20 ohms, and then 60 minus, next page we have all solution, 60 minus voltage for 20 ohms is giving you voltage for 15 ohms. Voltage for 15 ohms and 5 ohms. Okay, first of all, you are calculating voltage for 20 ohms, and 60 minus 50,6, because voltage for 20 ohms is 50,6. I hope it is clear. We have done. So they don't ask for now, but maybe next time they are going to ask you, calculate current on 15 ohms. Current for 15 ohms. How can we calculate? And current for 5 ohms, maybe they will ask. So let's answer these questions also. Let's say I1, I2. We can say I1 and I2. So how can we get I1 now? I1 is easy to calculate now because we know voltage for 15 ohms over resistance, V over R. So V is 9,4, and then resistance equals 15 ohms. So we can use our calculator. 9,4 over 15 equals 0,638. I hope it is fine. Next time, maybe they will ask this question. And then I2, how can we calculate? voltage over resistance now, but now your voltage is 9.4. How we know that? In parallel, we have same voltage. In parallel, we have same voltage, 9.4 over 5 now. And you can get 9.4 over 5 equals 1,88. 1,88A. This is our another option. So another question. And then we have another option to calculate I2. I2 from positive to negative this way. Our total resistance we know 2,53. 2,53A, we know that. And then if you calculate I1, to calculate I2, you can use this option, of course, because you know voltage and resistance. But you can use another option. I2 equals I total main current minus I1. That's another option. So we have 2,53 minus 0,63. Let's check that. 2,53 minus 0,63 equals 1.88 or 1.9. You can round up, it's fine. So we are getting our answer. As you see, you have two different options to get current. They don't ask for this question, but we just add, and then maybe next time they will ask. So when you are answering past papers, you can check what else they can ask from this question. Okay, by using this circuit or by using this question, what else they can add? For example, for this question, we said they can ask you current. Maybe next time they are going to add here internal resistance. They will add internal resistance and repeat question. Same thing, but what you are going to do when you calculate all external resistance plus internal resistance. All right, so this kind of questions they can ask during your metric exam, during your grade 12 final exam, even other exams, so final exams, even maybe June exam also they can ask, but grade 12 electric circuit questions like this. Thank you very much. See you next lesson.